Okay, so connecting slope and rate of change. So if you look, oh, sorry, this is Teresa, sorry, that's gonna mess me up, but this is Teresa. She is learning how to skateboard, and on the next animation you're gonna see the thing that they're doing. You can also follow along in Agile Mind. So this is, I'm gonna play. Notice Terrence is pulling her with a rope on a skateboard. So we're going to go ahead and we're going to copy that into our notebook. So we have time and distance. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's 0.7, 1.1, 1.5, 1.9, 2.3, 2.7, 3.1, 3.5, 3.9, 4.3, 4.7. So go ahead and write all of that into your notebook, and then we will continue on with Agile Mind. So now change to this next page or animation down at the bottom, and then it's going to have you click on the grid. Remember, if you don't actually do this with the video, then it's not going to say that you submitted. So 0, 0.7. So again, I need to move along the time axis, 0, and then I need to move up 0.7. Well, I can't go all the way up to 1, so I would have to go up like somewhere in there and then check. And I want you to do that. So go ahead, pause the video, and then do all of those and hit check after each one. And then once you've done that, we're going to graph it on paper. Okay, so I'm going to graph it. Notice it goes from 0 to 10. If you do not have a graph paper spiral, then remind me to get out the graph stamps. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I really made that way too big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm just going to white out because I made it way too big. You only need it to be a 10 by 10. So again, this is going to be time. This is going to be distance. It's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, oh, sorry. I need to move this out of the way for you. Okay, so you should have seen when you paused the video and you did all of those that you get points that look like that. So 0, 0.7 will be somewhere around in there. It's a little bit more than half. Then we go over to 1, up 1.1, go over to 2, 1.5, 3, 1.9, which would be really close to 2. 4 would be 2.3. 5 would be 2.7, so just over half. 6 would be 3.1. 7 would be 3.5, which would be halfway. 8 would be 3.9, almost 4. 9 would be 4.3, almost halfway up above 4. And then 10 would be 4.7. And then you can use a ruler or some straight edge to make that line. Okay, it's not going to be perfect, but try to get it as close to straight as you can. You can also play with the animation to try to get Teresa to move at a constant rate. And then yours looks a little bit different than mine. So now go to the next page. Notice you're going to see this right here. The y value of the point at which the graph crosses the y-axis is the y-intercept. I'm going to write that definition down. So, okay, let's try that again because they made another announcement. So then the y value of the point at which the graph crosses the y-axis. So I'm just going to say y-intercept. Notice it's where it crosses the y-axis. Remember, the y-axis is the one that goes up and down. The x-axis is the one that goes across. So time is x, distance is y. So the y-intercept is where crosses the y-axis. So the way I think about it is y-intercept. If you think about football, if you like football, interception is where like the football player catches the ball and then starts running with it. So intercept, it's where the y-axis is intercepting or catching the line. So it's also known as initial value. So if you get a highlighter, initial value, remember, is one of our vocabulary words. Y-intercept is the same thing. So y-intercept and initial, oh sorry, you couldn't even say it. Y-intercept and initial value, those are the same thing. Initial value is more of, we talk about it in terms of like time, is start value. Well, if you think about it, time is 0 on the y-axis, so it's the start value. It's the initial value. Okay? And then we talked about this a little bit last week, but I'm going to make sure. Notice this is a straight line. So since it is a straight line, we know it has to be a constant rate. Sorry, again, I don't know why I keep having it way too low. So it's a line, so it's a constant rate because it's got to be keep going up the same amount. The time for every time it changes, this rate has to be the same. So it's going at a constant rate because it's a straight line. If it wasn't, and there was a part of the line, and don't draw this, but if there was a part of the line that went this way, it would it wouldn't be a straight line. Or if it was like if they sped up, the steepness of the line, it would become steeper, or it could become like more flat. So if you look at it like that, that line would not be straight if it was changing the rate. So since it's a straight line, you know all of that has to have the same rate. It's not flatter, it's not steeper, it's just the same. Okay, so that's what you should read from that page. Please read through that stuff. Notice it says linear, constant rate, all of those things. Okay, now the next page. You should see this table, and then we're going to find the difference of the y values. So notice the time. How much is the time changing each time? Well, from 0 to 1, that increases by 1. Every time the x value from 1 to 2 is 1, 2 to 3, 1, 3 to 4, 1, 1, 1, 1, 1, 1. So it went 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this one, it goes from 0.7 to 1.1. It's typically hard, or sometimes decimals are harder to think about. So if you use a calculator, and we were trying to find how much this changed by, from 1.1 to 7, and my calculator's about to die, but it'll still work. I'm going to take 1.1 and I'm going to subtract 0.7. Remember the decimal is right down here? So I did 1.1 minus 0.7, and it tells me 0.4. Then I'm going to do 1.5 minus 1.1, and that's also 0.4. 1.9 minus 1.5, 0.4. And I'm going to keep doing that. 2.3 minus 1.9 is 0.4. Well, 3 plus 0.4 would be 0.7. 3, 4, 5, 6, 7. Then 7, 8, 9, 10, 11. So that one changes by 0.4. 0.1 to 0.5 is 0.4. 0.5 to 0.9 is 0.4. 0.9 to 0.3 would be 0.4. 0.3 to 0.7 would also be 0.4. And we said this side was changing by 1. And you can type all of that into Agile Mind. Make sure you're also writing it down, because this is what you'll go back and look at later, not what's in Agile Mind. Okay, so I'm going to put 0.4. And then I'm going to hit check. And that's all correct. Now watch what it does for the next one. It calls it delta. So this was change in X, change in Y, and it's also a triangle. You'll see us write a triangle for delta. Okay, now remember when we were talking about rate of change, we were talking about feet per second. So if you look at the very bottom, you see delta Y over delta X. And I'm going to write the word change. Is equal to something feet per second. And that came from those right there. So it's actually 0.4 feet per 1 second. Notice it's a constant rate like we said, because it's a straight line. So it's 0.4 feet per second, or 0.4 feet a second. So 0.4, 1, 0.4, check. And notice it's going to just show you from the graph. So it's going up 1/4 of a foot over every 1 foot. And I'm going to draw that on here. So it's going up 0.4 over 1, going up 0.4 over 1, 0.4 over 1. It's kind of hard to see that. So each time it went up 0.4 over 1. So that is the rate of change. Notice rate of change is also called slope. And so somewhere you need to write slope. We talked about it being slope, rise over run. So we talked about it being rise over run. Notice it's going up every time it goes over.